classes, does it store the recordings in the Zoom meeting? Like, how do you watch recordings for your teacher who's doing Zoom?
I don't specifically know how the meetings are, like, the recordings are stored, but they usually just send, like, a link, I guess, to watch the video. That's all I really know.
So, like, you get an email with a link?
Yeah.
Okay. Interesting, because one of my biggest time-consuming things is that Microsoft Teams sends me an email with the recording, then I have to download the recording, then I have to upload it to WeVideo, which I then have to break it into 15-minute chunks, publish it on YouTube, and then copy those YouTube links into our Canvas page, and that takes a million years. I didn't do yesterday's because I didn't have time. So it just like takes forever. And if there's anything that can cut down on that time, I am willing to do it. Okay. So we're going to do warm up. Let me see. 3. And this is IB seniors. Okay. So, all right, so we have evaluate this definite integral with an exponential function in it. Ted, can you help me out?
Hopefully.
Okay, good.
Let's see. So you redistribute the 2x first.
It's already as distributed as it can be.
Okay.
So, but what is this? Like, this is 2x itself is a function, right? It's a linear function.
Yes.
And it's inside of an exponential function. So what do we use to integrate functions inside of functions? Well, first, do you remember the term that describes a function inside of another function?
No.
Okay, composite.
Okay.
Okay, and composite functions require U substitution. Okay, so what is my U in this case, Ted?
The 2x.
Yes, very good. So if my U is 2x, what is my DU?
The 4e.
No, how do you do?
No, sorry, yeah, no. 2, just 2.
2 dx, yes. Okay, so we have our U and our DU, and so we look at our function, and we see, let me get some highlighters, that this 2x matches that, and we see that we have our dx here, and the only part left in the function that doesn't really match is a 4, and here we have a 2. So what can we multiply this entire equation by to turn this 2 into a 4?
2.
Yeah. So I'm going to multiply the entire equation by 2 to get that 2 du is equal to 4 dx. Okay. Now I can replace all of the blue stuff with the corresponding U stuff in blue. Okay. So now I'm going to sub everything in. So Ted, my integrals, we're going to leave the same. It's technically not correct to leave them the same, but we're just going to leave them the same for our sake. We're going to switch them back in a minute.
Okay.
So how do I sub all this stuff in, all the pink and blue that we highlighted? So the 4dx, we're going to rewrite as what?
2 du.
Yeah, so I know I need the 2, and I know that I need the du at the end. And then I still need my e because that was my function. And then what am I going to replace the 2x with?
4.
Huh?
Yeah. No, 2.
What was 2x equal to?
To u.
Yeah, good. So we're going to replace the 2x with a u.
Oh.
Are we good, Ted?
Probably no.
Okay,
Not
ask
yet.
your questions.
So you keep going, right?
Right, we're not done yet, but like,
Yeah.
do you have questions about how we went from here to there?
I don't think so, actually.
Okay, so all the substitutions we made make sense?
Yeah.
Okay, so now how do we integrate e to the u? This is the easiest integral we know.
It's 1.
Well, no.
Or no.
It
Okay.
stays the same, right?
Okay.
So we're just going to have 2 e to the u. That's all. Okay?
Okay.
And we're going to evaluate that from 1 to 2, but first we have to sub back in our u. Okay?
Mhm.
So how do I rewrite this chunk right here without a u in it? I want my x's back.
2e to the 2x.
Yeah, 2e to the 2x. And we're going to evaluate this from 1 to 2. We can check ourselves and look at this. The derivative of e to the 2x is going to be 2 times e to the 2x. And we already have a 2 coefficient here, so we would get 4e to the 2x, which is what we started with. Okay, so we see that we've integrated correctly, and we've switched back to our x's. So now once we've switched back, Ted, how do I evaluate this with my numbers in it?
You make 2 different equations, or you plug them in 2 different times.
Yeah.
The first one with the 2, and then with the 1, and subtract them from each other.
So 2e to the 2 times 2, and oh, is it plus or minus?
Minus.
Good, very good. And then 2e to the 2 times 1, which should give me 2e to the 4th minus 2e squared. You can leave it like that, or if you want to factor out everything you can factor this as 2e squared times e squared minus 1. Either of these solutions are good.
Okay.
I think that maybe you can see everything, but I'm still going to take the bottom away. Okay. What questions does anybody have about that process? Thank you for letting me pick on you, Ted, also.
Okay.
Okay. Does anybody have any questions about this process? Everybody is totally confident with composite functions, use substitution.
No, wait.
Okay.
Oh, no. I got it.
I'm confused.
Okay,
No,
bring it on.
Did you ask where? Am I confused?
Yeah. Well, I said bring it on, but ask your question.
I forgot how to do use substitution.
Okay.
Can you like go through again, because I lost it and like couldn't pick it back up.
Okay. So do you want me to talk back through going from step 1 to step 2?
Like, how many steps are there?
Kind of 3.
Then do all 3.
Okay, let me let somebody in. It sounded like somebody was trying to come in. Claire. Okay. All right, so the first thing is to recognize that it's a composite function, which is a function inside of a function, right? We have this linear function 2x inside of the exponential function e, right? Wade? Wade, turn your microphone on. You and I are going to chat through this.
Oh, perfect. Okay.
Okay, so do you understand that this is a composite function? Do you know what that looks
Yeah.
like? Okay, good. So then we know that when we do u sub, we pick the inside function as our u.
Mm-hmm.
Okay, then we take the derivative. Does this derivative make sense to you? The derivative
Yeah.
of
How do
is
you do
du.
that?
The derivative of 2x is 2, and then
Yeah.
we always just tack on a dx because we took the derivative with respect to
I'm
x.
gonna put notes for us on this.
That's right. Okay.
Okay. Then we look, we can sub in our u because we picked it, and we look and see what's left over. The e is just a function, okay? It's the base of our function, so we don't need to sub anything in there. What's left over is this 4 and this dx. We want to be able to replace those blue pieces. We have a 2 and a dx, so we know we've got the dx part, but we need this to be a 4 instead of a 2, right, Wade?
Yeah.
So we have to think of something that we can multiply the whole equation by to get that 4. To get this to be a 4, we can multiply everything by 2, which means that instead of just subbing back in a single du, we have to sub back in a 2 du into our equation to replace the 4 dx.
Okay.
Okay, I feel like that part so far has been the most difficult part to understand. What questions do you have about it?
Like, I know I've never had a problem with this, but it literally I cannot fathom how this works anymore.
So we're trying to replace the stuff that's already in the equation, right?
Yeah.
We've got a dx.
Oh, okay. I got you now.
We had a dx over here, and we can multiply this whole equation by a factor of 2 to force this piece to be 4 dx.
That's right. Okay, cool.
And then we can replace it with what we had over here, which was the 2 du.
Okay.
So in this, we replace the 2 and the du and the u. And we don't do anything with the e because the e is just the base of the function. It's a function. It's not like a number. Okay? Although it is a number, but that's how the function works. Then we integrate, sub back in our x, our u stuff in terms of x, and then we can sub in our exact values and get our answer. And the rest of that is just normal integration. Once we get past here, it's normal integration.
Cool.
Okay. I hope that clarified things for a lot of you. Does anybody else have any questions before we move on? Okay, so I'm going to go ahead and get started on the Venn diagram notes. Okay, so there should be a link on Canvas with these notes linked to it. Okay. If you want to just write them on notebook paper, that's totally fine. It doesn't bother me at all. You don't have to write like the EQ or things like that. Just to kind of like follow along as we go. Okay. Okay, so we're talking about Venn diagrams today. Okay, so there's some things that we need to talk about because this Venn diagrams also require us to talk about sets of values, which is actually a whole section of math, set theory. And you have to learn sets in order to take abstract algebra and things like that. So we're learning the very beginnings of that today. Okay, so A prime is going to be called the complement of A. Sometimes you might see this as A to the C, which just means A complement. Okay, so A prime or A to the C is going to be the complement of A. And it means it's the opposite of this set A. It's everything but A. Okay. Because it's everything but A, the probability of A happening plus the probability of the complement happening should equal 1.